Now we're going to look at the volumes of these different 3D shapes. So for prisms, we're going to multiply the base area times height. It kind of makes sense like we do with a rectangle, base times height. But this B is the capital B for area of the base. So we got to find the area of the base. In this prism picture, it would be a rectangle times the height. But it could be a triangular prism, hexagonal prism, octagonal prism, parallelogram prisms. So we need to know those different base areas and just multiply it by the height. A pyramid is just 1/3 of that. So that's an interesting thing to note, is that pyramids, if you put a pyramid inside perfectly into a prism of the same height, it would take up exactly 1/3 of the volume of that prism. So it's 1/3 of the prism volume. So that's something that really astounded people in time back ancient Greece when they discovered those kind of relationships. How amazing that is! It's actually exactly 1/3. And there's a lot of things like that. We'll see with the spheres too. For cylinders, this is the base area, pi r squared, is area of a circle, times height. So it's really the same thing, base area times height. And the cone is 1/3 of that, pi r squared height. So it's same idea, cone. If you fit a cone inside a prism of the same height, it'll take up 1/3 of the volume. And then a sphere, if we this was a famous formula that Archimedes found, and it was really pretty impressive how he came up with it. But again, he believes that one of his greatest works, he asked that it be put on his tombstone. But it's the fact that if you take the radius cubit times pi, and it's exactly 4/3, this ratio of 4/3 finds the volume of any sphere. Now if we're doing a hemisphere, the volume would be exactly half of that, 2/3 pi r cubed, because it would be half of that. Now notice the radius is to the third power, so if the radius is 5, it'd be 5 times 5 times 5 to the third power. So be careful of that. So let's look at some examples. Here's our triangular prism. Our base area we calculated over here. The triangle area, 1/2 base times height, is 6. The height of the prism is 10. So 6 times 10 be 60 cubic centimeters. Notice the units are now to the third power because we're counting how many little cubic centimeters, actual little cubes, fit inside that prism. It'd be exactly 60, even though it's triangular, which is kind of interesting. Here's a square pyramid. The volume is 1/3. Base times height, the base area is 16 because it's a square that's 4 by 4. 4 times 4 is 16. The height of the pyramid is 12, so we get 64 cubic centimeters. Exactly 64 cubic blocks, 1 centimeter on each side, would fit in that square pyramid. Here's our cylinder. Pi r squared h is our formula. That's our base area times the height. We plug in our radius of 4 and our height of 10. We get 160 pi cubic centimeters, which is about 503 cubic centimeters. So again, we can answer in terms of pi, the top one, or the approximate value. Either is fine. For the cone, the volume is 1/3 pi r squared h. Radius on our cone is 3. And the height is 8. Notice we're using the vertical up and down height, not the slant height. We don't need slant height to find volume. So we get 24 pi, or about 75 cubic centimeters. Here we have a hemisphere. Radius is 7. So we plug in, actually we'll talk about spheres later. So I'll leave that alone. So that's it for volume. and you can